was at a conference, ASCO conference, maybe 10 years ago, and after my talk, Leah Khan came up to me and spoke to me and asked me about the research we were doing and told me a little bit more about hub funds, and that's really how I became involved. She told me that they had a postdoctoral fellowship program and that I should apply, or at least have one of my postdocs apply. And I was lucky enough that that postdoc was awarded the fellowship. So his name was Pedro Medina. And since then I've been active. Pedro's doing fantastically well. I mean, when he was in my lab, he got a number of high-profile papers that have been highly cited. He ended up going on the job market himself after his postdoctoral fellowship and applied all around the United States and Europe, and turned down very nice offers here in the United States to take a position back home in Spain. And he's now an assistant professor at the University of Granada in Spain. And every one of the fellows that I can remember being associated with in this program has done well. They've either made fantastic discoveries, published very highly cited papers, and gone on to obtain their own faculty positions. And that is really the goal here, is to give these really smart young minds the opportunity to become their own drivers of cancer research. So to get them out of the sort of mentoring phase and into the independent phase, and it's really been a success. As scientists, we're not really in this for the money. There's not a major financial incentive to do what we do. What's really exciting for us, what really drives us, is the chance to make new discoveries, to sort of turn the telescope on the heavens and find something new. In our case, we're turning the telescope or the microscope into the cells and finding new genes that are involved in driving cell survival, cell life, cell division. And often those are the genes that turn out to be mutated in cancer. So we spend a lot of time investigating a part of our cells that was previously thought not to be very important for anything, but we've sort of realized that this trash dump in the cells, these sort of junk RNAs that were floating around in cells, are actually very, very important. I think that's been one of the main discoveries that my lab has made, and it was not really a eureka moment where we just sort of discovered this trash dump and found gold there, if you will. It's been a process where we found the trash dump, and then we dug deeper and deeper, and ultimately found very important new markers and new targets for cancer therapy. I mean, I see it as an essential part of my job to surround myself with really smart young people. You've probably also heard that most Nobel Prize-winning work is done when people are in their 20s and 30s. They only get the prize when they're 70, but the work they did was when they were in 20s and 30s. This is really the time of amazing intellectual spurts in people, and we need to encourage that. And I find that the most rewarding part of my job is to give these minds the opportunity to explore, to provide them a space to do that. A safe space where they can make mistakes, where they can make discoveries, and then go on to start their own groups, just like me, and sort of nurture the next generation. I would say it's been almost exponential in the last 10 years. There's the sort of sequencing of the human genome was criticized at the time as being a very expensive endeavor, and it was. It was a $3 billion effort or something to sequence all of the genes in our bodies, but it's really opened up a universe of new information that we didn't know about our own cells. We would not be where we are today were it not for the human genome. I'm saying, sorry, my lab's research, because tucked away in that genome are all these junk RNAs that now we work on as new markers and new therapeutics. The whole concept of personalized genomics or personalized therapeutics could only be possible because of the human genome sequence. And we're now poised where every cancer patient will get their genome sequenced. We'll scan through, look for the mutations in the genes in that patient, and tailor a therapy just to the genetic complement of that particular patient. So it's been revolutionary, absolutely. I would say in 10 years, the genome of every patient will become part of their electronic record. And as new information comes available about which genes are important, physicians can go back, scan the genome of that patient and be able to say which of the mutations that were found in that patient could actually be actionable, where there might be a new drug that could function even better than what the patient is currently on. I think, in terms of cancer research, it's going to be absolutely revolutionary. Other diseases are sort of catching up. There are many diseases out there that are also genetically encoded or sort of have a genetic component, and similar kinds of work will emerge in that area as well. There is a lot of collaboration going on in the world of cancer research. It's such a huge field. There's so much that we still don't understand. There's expertise all around the world, and so the great breakthroughs are truly happening because of collaborations between scientists throughout the world. We're fortunate here in the United States that some of the best research is being done right here. There's probably organizations like the Hope Funds that are providing funds for postdoctoral fellows to come and work here in the United States, and probably reflected in the fact that many of the postdoctoral fellows funded here are from Europe and Asia and other places. And so, yeah, definitely collaboration throughout the world is happening, a very important part of what we do. And the Hope Funds not only brings together the best postdoctoral fellows, but also the best postdoctoral mentors. Some of the scientists who've made the greatest discoveries in science, and that's a privilege, even for me, to be around those great minds.